Hello guys, welcome back to Tronic Synergy, and our series continues. So last time we did a full adder circuit and a half adder circuit. Now we are going to the side of subtracting, and today we are starting off with a half subtractor circuit, and this is the output that we expect. This is the truth table of the half subtractor circuit. The schematic is right here of the half subtractor circuit. So like usual, the NE555s, I'm just using them as the switches, and our main goal is to learn how to make this logic gate to give you the difference and the borrow. So what we expect is this. So my circuit is right here, and we are starting, so it's on already. So we're going to start this. So 0 minus 0, you get a 0 and a borrow 0. That's what you get. Then 0 minus 1, we get a 1 output and a 1 borrow. So 0 minus B, we put it on, we get a 1 green output, then the borrow red, orange rather. So 1 output and the orange representing the borrow. Then put it off. Then the next one, A is on, B is off. So 1 minus 0, we get 1 minus 0, we get a 1 output and a 0 borrow. So 1 output and a 0 borrow. Then the next one, 1 minus 1, we get a 0 output and a 0 borrow. So 1 minus 1, so put this on. So 1 minus 1, we get a 0 on both input and the borrow. And that's what we are going to do today. Please enjoy. So welcome back guys, and we are continuing with our today's session. So today we are doing a half subtractor circuit. I've already done a full adder and a half adder. Then we are going to start in this subtractor circuit. So we are going to start off with the half subtractor circuit. It's a very easy, it's even easier than the half adder circuit, because it only uses 3 logic gates: an XOR, this an XOR, this is an inverter, it's a NOT gate, and this is the AND gate. Yes, so those are the only logic gates that we need in order to make a half adder circuit. And this session right here, I told you, don't even bother about it. Next time I'm going to buy a deep switch rather than using integrated circuit or NE555s in bistable mode to work as switches. So next time I'm going to come with a deep switch, and it's going to be much easier on the breadboard. So today this is our circuit, and we are moving more closer in order in making an ALU, arithmetic logic unit, and that we are going to do maybe in the next like 3 videos. We will be able to make our first ALU, as just a simple ALU, which will be having the subtractor circuits and the adder circuits, and we'll move on from that point. So my circuit is right there, remember. So this side just represent the switches. And if you want to learn how to make an NE555 in bistable mode, I'm going to put a link in my in the description, so you're going to check it, and you can go and see how to connect an NE555 in bistable mode. Then so after you have connected that, so the outputs A, so the first NE555 gives the output of A, we're going to call this A, and the next gives B. So A and B first enter an XOR gate. Once they enter the XOR gate, the same inputs of the XOR gate enter. The one for A enters a NOT gate before entering into an AND gate. Then the one for B enters direct an AND gate. which the output of the AND gate will give us the borrow, and the output of the XOR gate will give us the difference. And then the logic, and then the truth table is right here. So when both the inputs are on, you get a 0 output and a 0 borrow. When A is off and B is when both the inputs are off, you get a 0. So when A is off and B is on, we get a 1 output and a 1 borrow. When A is on and B is off, we get a 1 output and a 0 borrow. Then when both inputs are on, we get a 0 output and a 0 borrow. So my circuit is right here, and we are using a 5 volts power supply. This is a 5 volt power supply. Use any from 3 to 9 volts, but you need to check the ratings of the integrated circuits that you're using in order to avoid damaging them. So the circuit is right here. So the NE555s, two NE555s working as a switches in bistable mode are right here. So first NE555, the second NE555, and then I'm using push button switches. So next time I'm going to put a deep switch, which is going to be representing all these circuits rather than using all these. Looks a bit complicated. So yes, so and then the output of the NE555s taken as, sorry, just put this right there. Yeah, the outputs of the NE555 with these white jumpers are taken as A and B, and they enter the different logic gates. So just like the last time, I don't have an XOR gate, so I need to make it. So that's why you see a couple of wires. I don't have an XOR gate, so I need to make it using an OR gate, AND gate, and the NOT gate. But next time I'm going to come with an XOR gate to simplify my connection, and it will be more simple than having that. So yes, so XOR gate, and then we have a NOT gate. This is a NOT gate TC04, and then an AND gate right there in the middle, 7408. And OR gate is right here, which is I think it's a 7432. Yeah, yes. So our outputs are right here. Green LED is showing the difference. Then the orange LED shows the borrow. So we'll go ahead and check our, and start our connection. Just pull this off. Just come on like that. Okay, just put it just like that. Hope you're seeing, not blocking these numbers. Yes, so we're going to start, and we're going to follow this truth table to see if it performs in the same way as the truth table. So when all inputs is already on, so when all inputs are 0, we get a 0 output, green is off, and a 0 borrow, orange is off. Yes, the next one, A is off but B is on. So 0 minus 1, we get a 1 output and a 1 borrow. So we put B on, and we get a 1 output and a 1 borrow. Green LED is on, that's the difference, and then orange LED shows the borrow. So 1 output and 1 borrow. So that's correct. Then A in the next one, which is right here, A is on but B is off. So we turn off B, then we put on A, and we get that A is on and B is off. We get a 1 output and a 0 borrow. 1 output and a 0 borrow. So green LED is on, orange LED is off. So 1 output and a 0 borrow. Then the last one, when all inputs are on, A and B, so I put this on. When all inputs are on, we get a 0 output and a 0 borrow. So 0 output and a 0 borrow. And that's what the circuit does. So that's basically how a half subtractor works. And next time I'm going to do a full subtractor, and we'll move on from that position. So let's do that again and see the connection. So when all inputs are off, the output is off and the borrow is off. When B is on, the output is 1 and the borrow is 1. So when B is on, output is 1, borrow is 1. So then the next one, A is on and B is off, so we turn off B, and we turn on A, so 1, yes, and a 0 at B, we get a 1 output green and a 0 borrow, yes. Then the next one, when all inputs are on, we get a 0 output and a 0 borrow. When all inputs are on, 0 output and a 0 borrow. And that's our half subtractor circuit. So thank you very much guys for watching. Please subscribe to Tronic Energy, where we do fun stuff all day, all time.